Solve problem 4.9 for Microelectronic Circuits, 8th edition by Sedra and Smith. For the rectifier circuit, let the input sine wave have a 120 volt root mean square value and assume the diode to be ideal. Let's briefly just review what root mean square value means. So basically, if this is my Vn, we know it's some kind of sine wave. The root mean square value is the sum of square of all values. It's the square root of the mean square of all the values. So that's where we're getting this 120 volts from. And we know that the root mean square value is equal to the maximum value divided by square root of 2. That's why this value is important. So if this is Vmax, we can easily find the other value. So knowing this, we can select a suitable value for R so that the peak diode current does not exceed 40 milliamps. So we know that V is equal to IR, so therefore R is equal to V over I. And since we're trying to find the value of R so that the peak diode current doesn't exceed 40 milliamps, that means we want to use this Vmax value, right? So we're going to say Vmax is equal to VRMS times the square root of 2. So R will be equal to VRMS, 120 volts, multiplied by the square root of 2, divided by our peak diode current of 40 milliamps. And then let me get my calculator out. Still, I get about 4.2 kilo ohms. So this is the smallest resistance that we would want in order to prevent the current from exceeding 40 milliamps. And then the greatest reverse voltage that will appear across the diode. So that would just be when this diode is cut off, and that would just simply be equal to the maximum. So that's equal to 120 times the square root of 2, which is 169.7 volts. And that's it.